Hello, how are we all doing? Good? Yeah, that one person, thank you very much. Enthusiasm on a Thursday morning. I'm Martin Beeby, I'm a Principal Developer Advocate at AWS, and I'm going to be talking about building real-time serverless apps in Blazor using AWS. It's quite the mouthful of a title. I'm at the Beebs on Twitter. Feel free to follow me on there. We're going to be discussing, oh, my clicker's not even working. We're going to be discussing what I mean by real-time applications and clarify that before we get going. And then we're going to be looking at how we build real-time applications using SignalR and how you might be doing that today. And I'll take an example of an existing SignalR application and show you how that would work in AWS. Then I would sort of look at a new way of architecting the same sort of application but using serverless technologies. And then finally, we're going to look about integrating that, or how we'd go about integrating that into a Blazor application. This is possibly, personally, the most important slide. Has anyone got a camera phone here? And anyone got a camera phone which has got access to Twitter? If someone could take a picture of me in front of this slide, it would be really awesome. And the reason it's important for me, it's called my inception slide, and it's me standing in front of a slide, 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 in front of a slide. It's 42 levels deep. Unforked, like I've actually got 82 pictures of me standing in front of slides, but they're not all unique, like in a line. But this one is in a line, so if someone can tweet that at me, at the Beebs Inception, then I will somehow get to level 42 or 43. And I'm speaking tonight as well in Leeds, so hopefully I'll get to 43 or 44. And the goal of this exercise is to get to level 100, which I think will be a lifetime achievement, frankly. I'm a software developer. I've been a software developer since I was 16 years old. I have been developing now for nearly 21 years. I've not updated my slide. I'll do the maths on that. That makes me 21 years old. And I work at Amazon Web Services. I previously worked at Oracle for a year. And prior to that, worked at Microsoft for 8 years as a software engineer and also as an evangelist. So what are we talking about today? What's real time, or what do I mean by real time? And there's lots of differences, and lots of people give different terminology around real time, so I thought I'd just clarify what I mean by it. I mean interactive apps and websites which react to events that happen in the real world. I'm not talking about building really, really low latency sort of trading applications and that sort of thing. I'm talking more about kind of building regular kind of applications which don't require the same level of like low latency which some of those sorts of hard real-time applications might require. So some people will refer to this as soft real-time, but I'll just call it real-time. Real-time's kind of all around us. It's in applications which we all use: mobile applications, browser-based applications, IoT devices, any kind of device which you use has probably got some level of real-time activity and sort of application programming model. So if you're thinking about something like WhatsApp and you're sending messages, obviously the messages which are being sent, that's happening in real time, and somehow they are processing those things and sending you events when you get new messages. But also like more subtle things in that application, like when someone's read your message, you get this double ticks, or when it's been delivered, you get a single tick. Those events are things that have happened in the real world which are getting fed back to you in the user interface. And that's a real-time notification which is happening. And on mobile phones, there is obviously the notification and push systems. But generally speaking, when we're building real-time applications, we're still very much relying on WebSockets and web protocols. So things like banking alerts or news story updates. If you're ever on a news website, and a breaking alert comes up and it pops up and says there's a breaking news story, they had to push that event to you. And that ability to be able to push stuff from the server to client is what real-time really is. Because the whole basis of the web was built by Tim Berners-Lee and his bunker in CERN on the basis of going to a website, requesting something from a server, and the server responding to your request. It was never based upon the idea that the server would have some new information and send it to the user. So over the years, we've developed techniques from long polling through to server-sent events through to WebSockets to enable us to do real-time applications. And every kind of application, shared whiteboards, VR and AR experiences in things like HoloLens when you're trying to update the position of other people in the experience that you're in. That's all real-time information. Document collaboration, if you've ever used Google Docs and you're working together with other people, that's all happening over some form of real-time collaboration, real-time application platform. And then if you're now inside a Visual Studio and you're doing like live share and you're pairing with someone which is in a remote region or somewhere which is not in your, in your app. I'll say one thing about live share, which I'm not that happy with, is the fact that now I have to do, I have to have my peers review my code in real time. That used to be one of the advantages of working remote, is that no one knew how bad I was. So, but now we've got with real-time collaboration, we can figure out just how bad I am in real time. So that's cool. And so, but all of those things are using under the covers some form of real-time technology. And those ones in particular, they're using SignalR, that particular one with live share. And if you ever use Microsoft Office online, that's using SignalR under the covers. And there's other libraries and frameworks like Socket.io and in Node and various other different platforms. But it's all about giving the user sort of feedback about events that are happening in the world. And so I might be on this is the hotel I stayed in last night, just down the road here in Westminster. And I was on this website, and the website just pops up this saying, just booked 52 properties like DoubleTree in Hilton, London were just booked in the last 15 minutes on your site. You've got to book this website now. It's got to book it now because it's going to go. You're going to lose your hotel. This is slightly illegal, this sort of capability now, but this is like a real-time event that someone had just booked that hotel whilst you were looking at that hotel, and they're giving you that information to try and encourage you to go and buy that hotel. And it's, what they could have also done is just have a JavaScript timer on 30 seconds and just pop that up. It might not be a real-time thing. It depends how good an engineering job they've done. But the idea is that it's a real-time event which is being pushed to the user based upon something which is happening in the real world. We use a collaboration tool called Quip at AWS. I think it's by Salesforce that build it. And if you produce a document and you share it, you can see all the people which are currently looking at that document. So you can see those two people viewing that marketing budget review. And usually this is, I always find this is a fun game, is that if you send an email out and say, hey, could someone review my document? And you'll find that no one views it. What you can do is say, can someone review their document? I've included the salaries of all the people in the department. Everyone starts viewing it, and you start seeing people show up there. But that viewing that's real time, right? When those other users go to that browser, that fires an event. That event gets sent to a centralized system. That centralized system then distributes it to the other connected clients and shows them who's viewing and looking at that document. In the same application, there's a chat sort of feature, and Ron Swanson's typing, and he's trying to type a message. This is possibly one of the most annoying UI elements in the world, by the way. The ... they're typing. I've lost many an hour on WhatsApp. Oh, they're typing. I wonder what they're going to say. Oh, they're not typing anymore. Oh, they're typing. Oh, no, they're not. Yeah, so anyway, but that's happening, as he touches the keyboard in his application, that's sending an event to some centralized service that's ultimately updating my UI to say that they're typing. So the main way that this is happening, the main technology that people are using is WebSockets. That's although that's not completely true in that there are many examples of real-time applications which are using other techniques like long polling and various other things. But for the majority of times, it's WebSockets. And WebSockets requires both the application and the server to support the WebSocket capability. This was like a standard which was defined by a working group and then implemented by all of the browsers. It's also been implemented in practically every application platform. The ability to create a WebSocket, you could do that from a C# console, for example. Console application, you could do it from an iOS application, you could do it from an Android application, you can do it in a web browser, creating a WebSocket to communicate information. And the way it works is there's a negotiation which happens between the app and the server. Because when it was initially launched, not every app and not every server, or not every client, maybe that's probably a better word, and not every server supported WebSockets. So they have this handshake negotiation over port 80. It's a HTTP request which goes from client to server, which says, I support WebSockets, do you support WebSockets? And then the web server says, of course, it's 2020, of course I support WebSockets. And then they create a channel a duplex communication channel, a way that not only the client can send information, but the server can send information back to the client at will, as long as the connection is maintained. And so what's good about a WebSocket is also, with a HTTP request, every time you make a HTTP request, you get everything, all of the payload, like includes things like cookies, things about everything. It's all included on every single request. So it's quite a heavy thing to make a HTTP request. It includes information about what browser you're using. All that stuff gets transferred with every HTTP request. With WebSockets, on the negotiation, that information is shared. But once a WebSocket is established, the information which is passed back and forth is just the messages. So it means it's much lower. Once you've established a WebSocket connection, you get much lower latency sort of connections between to a client and a server. So I got involved very much in real-time stuff when SignalR originally came out for .NET the full fat framework. And David Fowler, I started following David Fowler and like obsessing over every project that he ever worked on because he's a genius. But the SignalR was one which was particularly interesting because it was building a really simple framework to enable us to do real-time stuff. And SignalR still to this day remains one of my most favorite frameworks I've ever used. It's a fantastic sort of developer productivity way of building things, and it's fantastic. And when I joined AWS, I had a SignalR project, and I thought, well, how would I actually run a SignalR project on AWS? What would I need to do? What sorts of things would I need to install? So SignalR, if you've not used it before or seen it before, it's just an open source sort of framework for basically doing WebSockets. It does a little bit more than just WebSockets, but it does WebSockets communication in real time. It makes it very, very simple to write real-time applications. And it's effectively an MVC application. So you end up with an MVC application, and you can deploy it to your IIS web server. And as long as the IIS web server has its WebSockets port open, and it's a new enough version of IIS, then you will be pretty easy to just go and create a client, a web application, which just connects up to the SignalR hub. And it will communicate using some JavaScript libraries, which have been developed, part of the SignalR framework. And if you've got one single machine on the back end, everything will be absolutely fine, because the client will connect to one single server, and there's no real complication in that. But it starts becoming more complicated when you add more than one server. Because I mentioned that a WebSocket communication is between a single client and a single server. That's like a pipe, imagining, between the two of them. And so if you've got a load balance system, and a user comes back to the load balancer and is assigned a different machine, that pipe is no longer, like the client thinks the pipe still exists because it's assuming it's speaking to the same machine, but the server's like, I've never seen you before. And so it disrupts the transmission. So one thing that you'll have to do with whatever system you're using, if you're using a load balancer, is you'll have to make sure that your load balancer supports sticky sessions. The idea being that when you connect to the load balancer will send you to a machine, and then subsequently, on subsequent requests, will always send you back to that same machine. That's what we call sticky sessions in a load balancer. Amazon have a very good PaaS service, I guess, platform as a service offering called Elastic Beanstalk. And it's basically pretty much any web application framework you want to use, like whether it's Ruby or whether it's PHP or whether it's .NET. You build your application, you send your code over to Elastic Beanstalk, and then they'll deploy it on a number of servers. And you can say, I want one server, or I want 5 servers. And the idea is they manage the servers and they manage the code. It was like, doesn't sound revolutionary, but that at the time when it was released in 2010, Elastic Beanstalk was like one of the very first sort of offerings like that. And obviously, we've got different services now around containers, and there's different ways of doing this stuff. But Elastic Beanstalk still exists, and lots of customers use it. And it's a great way of deploying, your first application. In Visual Studio, if you have the AWS toolkit installed in Visual Studio, you can just right-click a project, say publish to Elastic Beanstalk. It will wrap up your application, publish it to Elastic Beanstalk, and do everything you need to right from within Visual Studio. It's relatively straightforward to do that sort of stuff. So I did that with my SignalR application. I deployed it to Elastic Beanstalk. I configured the load balancer to make sure that I had sticky sessions, and boom, everything kind of worked. Well, one thing I had to change is when it deploys to Elastic Beanstalk, you have this sort of arbitrary PowerShell file, which you can include in the manifest, and that can affect the machine that you land on. So when you go to the one thing I did was just add the ability to open WebSockets on IIS because they're not by default open. So when it deploys, when Elastic Beanstalk deploys my application to a website, it opens the WebSockets, and SignalR just works, and it was brilliant. So to show you that app that I ported, I've got this. I've got one here. So if I've got an NDC session. So if you go to this URL, if anyone has an internet connection, hopefully you guys do. So if I take a photo of that QR code, it'll take me to what should have said. Let me just. People should be seeing now on their screen, please wait. What was that beep? That was like a server malfunction. That was like a post from a motherboard which had gone wrong. Does anyone see this, please wait, or is it just me? Yeah. So there's enough of you to prove that this works, right? So in the application, I'm going to press, I think it's a Vue.js application, and I'm using Reveal.js to do the slides, right? Now, if I go to a next slide, what should happen on your machine is on your phones, you should get a question. What drink, coffee or beer? And if you vote, which some of you are doing, it will start sending messages. Now, if you think, when I moved the slide, that sent an event that sent a message to all of your connected phones and basically pushed you to the right question. When you press the button, that sends a message to everybody about your voting and what you voted for. And you'll see as it's going, it's kind of circling around. Tabs versus spaces. Something quite weird going on. It's a very close call. Just to quickly look at the, if I just go in here and go to developer tools, and I'm just going to refresh this. I'll just pop it to another screen here. And you'll see that I have a WebSocket connection to this thing called Voting Hub. This is how SignalR works. There should be a negotiate somewhere. That's the HTTP request which happened to make the negotiation with the WebSocket. And then we have this Voting Hub connection, which is basically our connection to our WebSocket. And you'll see that there's lots of WebSocket messages which are being passed. So you can actually view this in Chrome. You can look at the messages which are passed by a WebSocket, and you can see that this is just a piece of JSON which is coming down, and some of them is going up, and various other bits and pieces. But as people vote on the system, it will update in real time. You'll be getting these WebSocket notifications. So that's like simple application deployed to Elastic Beanstalk, and it kind of works okay-ish. But there's problems with it. And one of the problems is when you're in a room like this and you have a number of people connecting, there's only a limited number of connections that you can have against a single server. So if I want to support 100 people, I might need maybe more than that. If I want to support 1,000 people, I'll probably need two servers, two relatively large servers. One server probably would become overwhelmed with connections. It wouldn't be able to maintain enough connections to support everyone. So you can start seeing there's a sort of like problem that if you want to have more than, if you want to support 1,000 people or 10,000 people or 100,000 people concurrently in an experience, you have to then have a lot of servers to back that up. And it becomes more complicated because there's still this connection between the client and the server, but when you've got like a bank of servers, you can only communicate with the other clients which are connected to the same server. You can't communicate to, if it was a chat application, let's say, and you were connected via this sort of system, you'd be connected to one server, and I couldn't chat to anyone on any other of the servers. Like, there was no way of sort of passing messages between the different servers. It's just sort of one way. So to solve that problem, SignalR has a capability of adding a thing called a backplane. And a backplane's like it's a distributed a pub/sub system of some description. I don't quite know why exactly, but Redis was always picked as the way that they did in SignalR. You did it. Redis has not only is it a cache, it also has a pub/sub mechanism that you can use, and basically it means that this backplane will make sure that messages not only get passed between the servers. So if you were building a chat application, you can be assured that if you sent a message to one server, that message would then get redistributed across all of the servers, or as many of the servers as you wanted to. But now we're getting more complicated. We've got a load balancer. We need quite a big cluster of machines, depending on how many people we need to support. And then we need this backplane. Well, that's a big cluster. That's got a number of machines. If I want high availability, I need at least 3 machines. All of a sudden, I've got quite an expensive system for a voting application. It's becoming quite difficult to justify this, potentially. So to add SignalR support, by the way, to Redis, it's really straightforward. In your MVC application, you basically, where you would ordinarily in the services write services.add SignalR, you just also include .add stack exchange Redis, because it's using the open source Redis connection, which has been developed by Stack Exchange. And then point it to your Redis server, provide it with a channel prefix, because often you'll be using a backplane across multiple applications, so you use a channel to do the subpub. And then that's it. You don't have to set any servers up or anything. SignalR just is magic. This is why I think David Fowler's a genius. But it's so simple to set up and make it distributed that it's pretty cool. But it doesn't stop it being expensive if you want to scale it out. It starts being complicated. There's lots of things that can go wrong. And generally, the projects that I've worked on based on SignalR, stuff goes wrong lots. It's very difficult to keep this stuff working and running smoothly. So I was at reInvent in 2018. And I was watching a session by people which are completely unrelated to the kind of work that I was doing, but they were talking about serverless applications. It's something I'm really interested in, this concept of serverless applications. Serverless applications being applications that you construct out of functions, these Lambda functions in AWS's case, which have small pieces of business logic. And then you use something which stands in front of those pieces of logic, which then distributes the requests. In lots of cases in AWS, we use a thing called API gateway. An API gateway sits in front of our Lambdas and or maybe not just our Lambdas, it can sit in front of our containerized application, it can sit in front of any kind of application. And it can do some interesting stuff, like it can take a request in, it could convert that request and then send it out to a system. Or it could modify the request coming in and send different requests to different systems. Or it could get the response coming back from the system and convert it in some way, maybe transform it into a different thing and then send it out to something else. So you have the API gateway is like a real sort of interesting sort of proxy gateway. It's a gateway. It's a really interesting gateway for designing APIs. And what they did at reInvent 2018 was this was usually for REST APIs. What they announced was this capability of WebSocket support. And they said, well, we're going to allow API gateways now going to have WebSocket support. So your clients will connect to WebSockets to Web API Gateway, and then that will send information to us. And it blew my mind as to how this even works. And so this is roughly the basis of what I'm going to be explaining to you and showing you how you can sort of re-architect applications like this to use a managed service like WebSockets Amazon API Gateway. Obviously, it should go without saying that Amazon API Gateway has been built from the ground up for scale. Some of our customers are enormous in terms of the scale of what they do. And many of our customers are using API Gateway to build their applications. So out of the gate, what you'll find with Gateway is that it should be able to support most kinds of workloads, and you should be able to do many sort of concurrent requests coming in at the same time, and it shouldn't really falter. There are limits and service limits, obviously, attached to the WebSockets API. There's some of them are soft limits and some of them are hard limits that we can remove. But for the most part, for the kinds of applications that I build, I don't even touch. I don't even scare it slightly in terms of its scalability. So the way that this programming model works is you have Amazon API WebSockets Gateway WebSockets API, which is like this managed service that you pay for, effectively, which sits there waiting for requests to come in. You have your IoT devices, your dashboards, your chat applications, your mobile applications. Rather than connecting to a SignalR hub inside your application, it connects to a WebSocket, which is hosted and managed by this system. When a request comes in, it is sent to other backend stuff. It could be a Lambda function, it could be a regular API, it could be whatever compute you've got there. What's important is that it's stateless, the backend. The backend has no concept of that it's working in real time. It doesn't use WebSockets at all. It's just being evented via REST or via invocation by the gateway. So the gateway is doing all the clever things about maintaining the stateful connections, and your application can just sit there in bliss, working statelessly. And obviously, because of that, it's much easier to scale those sorts of applications. So the way it works, if you build an API, and you get a WebSocket endpoint. This is a secure socket, WSS. You'll get some unique ID, execute.api, the region, amazon.aws.com, and then the stage. So you might have like different stages, production, development, test, or whatever. And so your applications will connect up into the API gateway. And when a message comes into the API gateway, it gets transferred to some backend service. Now you can basically route any request to any system, but in this example, I'm going to route it to a serverless backend built in Lambda. So it will invoke it, but what's interesting is when it invokes it, it comes along with a connection ID. And that connection ID uniquely identifies the user which sent the request. So you end up with an invoke, a connection ID, and then what I do in my application is when they connect, I store that connection ID in a cache. In a database, actually. I use DynamoDB. So I just take the connection IDs and put them in a database table. So now anyone which connects to my application, I've got this long list of all the people which are connected to it. So that's cool. One client is being able to connect to the application, and they'll be able to send messages to the API gateway. And if they send, like, over the WebSocket, 3 WebSocket messages, that gets translated as 3 invocations of my Lambda function. So my Lambda function doesn't just get sent 3 messages, it gets invoked 3 times. So it's completely stateless on this side, and it gets past this connection ID, Lambda function, I store some stuff in DynamoDB when it connects. So we've got one-way communication at the way. So how does the Lambda function speak to these people? Well, it uses this connection ID. The API gateway provides a thing called a connection URL. And a connection URL gives you a sort of a unique name, execute API, US West 1, Amazon.aws.com, environment, connections, and then you can pass a connection ID. And if you pass that connection ID, it's like a REST endpoint. You can call it, and you can send messages to it. And what will happen is that's being sent to API Gateway. API Gateway will take that REST that information, that message, and it will route it to the WebSocket connection of that connection ID. So it will start routing messages back and forth. So it's doing all the heavy lifting of maintaining the WebSocket connections, and you're just using REST, basically, to send messages to those different connections. And the way that you basically pick different users is by the connection ID. So that connection URL has a couple of features. One is you can post to it, which means that you send a message from the server to the client. The other thing you can do is you can do a GET request, and it would basically say what the last known state of that WebSocket is. Because obviously, WebSockets disconnect all the time. So you might want to know if it's been disconnected, if it's still active or not. Or you might actively want to say, I don't want them to be connected anymore. I want to delete them from the service. So I'm going to delete or disconnect their WebSocket connection for whatever reason. So it's a REST API. You can send a post, get, or delete to it, and it will either send a message, it will get the status, or it will delete the WebSocket connection. So if I wanted to create one of these things, I go into the API Gateway console. I say, I want to create an API. I'll choose a WebSocket API. I give the API a name. I use a route selection expression. This is how we route the request coming in to the correct portion of our system. So the request.body message, the request.body message is Even in a video, I make mistakes. Request.body message is where we store the routing information. So basically, when we craft our message, that will be, if we pass in the root connect, it will connect to this thing, and we're saying we're going to integrate with a Lambda function, and we're going to send it over to this particular Lambda function. I've obviously uploaded a Lambda function previously. On connection function. OK. So when they connect, they're going to call that Lambda function. When the WebSocket disconnects, like when the browser sends a disconnect command, it's going to call this function. And then I want to create a send message route. So when they want to send a message, I want to create a way of them sending a message. So I create a new route. And I basically say, I want to pass that over to a Lambda function. I could pass that over to anything. It could be a Docker container. It could be Kubernetes. It could be whatever. But I'm going to pass it over to a send message function. And then I go and deploy that API. I create a new stage. I'll say I want to put it on production or prod. The idea of me deploying anything to production anymore is laughable. But let's give it a little description. You don't actually need to do that. But we deploy it. And then what will happen is you get that WebSocket URL at the top for your URL. You can just basically start using that from any client which supports WebSockets, and the connection URL, which you can start using inside of your Lambda functions to sort of execute and pass information back and forth. So like the way that you craft these headers or these messages in the WebSockets is really important. So this message, would be routed to the send message Lambda function, and the data that's going to be transferring over is hello NDC. So my Lambda function will basically get that piece of data and it can do something with it. If this was a chat application, it might store that information in a database. It might decide to distribute that to everybody in the channel or whatever. But it's the Lambda function which actually does the clever stuff potentially. So I end up with an architecture like this. So rather than having my single application, I've got an API gateway. The route's based upon the action header or the message header, which I talked about earlier. And when someone connects to the device, so when they create a WebSocket, it creates by default this onConnect event. That will get sent to the onConnect Lambda. What I do is I take the connection ID and I store it in a database, and that's all I do with it. And then when they connect and they want to send a message, I go to send a message, and I take their message that they're sending, and I get a list of all the current connections, and I basically loop through every connection and post to each connection the message, and it gets distributed to everybody. That makes sense. And then I've got one last Lambda function which does a disconnect. And basically, if you call that with a connection ID, it says disconnect, I'll remove your connection ID from the database. So this database should be basically a growing and decreasing list of all the current connections which I can call. So from my application, I can call anyone which is connected with, from any system, as long as I can access the connection IDs, I can just call them. So it's stateless. It's stateless in the way that the sort of model of it. I'll just quickly show you, I don't know if you, so a Lambda function looks something like that. And if you want to know how I did that, I'll maybe tell you over a bit later. So, but a Lambda function looks like this. Basically, it's a function, and there's an input, there's a Lambda context, and this particular function just returns input to upper. So uppercase is whatever gets sent to it. Like, it's really simple business logic. That would be the worst Lambda function in the world, but it's something that you could do, right? So my application, my send message application, it's a little bit more complicated. I'm not going to go into exactly what it does. It basically does DynamoDB gets all the connection IDs, and then over on over somewhere here, on line 674, it loops through all the connections and it posts the message to all of the different connections. So my send message Lambda function is quite straightforward. It gets the list of connections, it takes the message, and it posts the message to all of the connected clients. So let's see if this works. So this is a chat. This one is, This is on chat.thebeebs. Now, I've created this little sort of demo thing where I can actually paste any WebSocket connection. I pre-pid it with one which currently exists. And if you go to chat.thebeebs.net and click connect, it connects up to that WebSocket URL, and then hopefully it should work. Yeah, other people have figured out how to work this as well. So you've gone to that URL and you're typing in your message, you've connected to that WebSocket, and now stuff's yo, blah, hello NDC, data sent. So stuff is happening. This is all using those 3 Lambda functions. It's and this basically server stateless application. So this is just a HTML page. God, this is really dangerous, isn't it? We're safe. Yeah. So we've got the this application. This is just a Vue.js application. It's I can host this in S3. You know, AWS. I can host it on anything which supports some static websites is what I'm trying to get out. So I don't need anything very complicated to host this kind of application. It's just static websites. And that's what's interesting about Blazor WebAssembly is I can compile that to just run on anything which hosts static websites. So I host my Blazor WebAssembly applications on a thing called Amplify console, which is like a little DevOps thing where I basically connect up a GitHub to Amplify console. It deploys or builds my Blazor application. It then deploys it to a S3. It puts a CloudFront in front of it. It then connects a SSL certificate, and so that I've got basically this hosted free SSL website, and it costs nothing or very, very little, pennies to run every month. And that's how I host my Blazor applications at the moment, my WebAssembly Blazor applications. And so I was looking at Blazor and was thinking, well, how could I build something like this in Blazor, and like what would I need to do, and what's the sort of journey which I have to go on to get that to work? So I don't know if you've looked much into Blazor. I started looking into it about a year ago, just interested, really. I follow Steve Sanderson religiously ever since he wrote the Rocks MVC3 book. And also when he wrote knockout.js, like I was writing a lot of knockout stuff. So I was really following Steve, and he was talking an awful lot about Blazor. He actually spoke at an event that I ran in 2015 where he showed WebAssembly and showed the kind of idea that you could compile C++ into something which could execute and run in the browser. So he pre-compiled on stage for us SQLite and ran it in the browser. And it kind of blew my mind a little bit. And then he just said something at the end. He says, I've kind of got this idea that maybe you could run a managed language in this, if you were crazy enough to do that. And it turns out that he was the crazy enough guy to go and do that. And he built this whole concept that now you can run .NET in WebAssembly in the browser with no plugins, and it's just executing inside the browser, C# executing in the browser. So I'm a big fan of Blazor WebAssembly. They also have another thing called Blazor Server, which is the same sort of concept, but it uses SignalR to do the actual portion, the rendering of certain portions of it. I'm not so familiar with this hosting model, and they're using SignalR here not necessarily to do real-time communications. What they're doing is taking advantage of the low latency of WebSockets to be able to pass back and forth between the server, and the server's rendering stuff. So it's a bit like a server-client rendering model, but they're doing little bits at a time over a WebSocket, and it's rendering the stuff on the back and passing it forward to the browser. So there's 2 different ways you can build stuff. I'm particularly interested in this Blazor WebAssembly. I think that's where the interesting stuff happens, and I think this sounds like a scaling. I don't know how that works, or if it will. But anyway, so I thought, well, how do I take that application that I built there, coffee versus beer or tabs versus spaces, and how would I, because that's built in SignalR, by the way, that's not built using this Lambda function sort of scenario, and it's not using Blazor, it's using Vue.js. How do I do that in Blazor? So I started going on this journey, and I went to Blazor, build client apps with C#. Who wouldn't love doing that? I was a buyer. I bought Silverlight, so I'm definitely going to buy this. And that went great. I mean, yeah, it went great. So .NET New, I had to do an installation of the templates to get Blazor WebAssembly working. So .NET New, Microsoft ASP.NET, you can read that command. And then you can run a template or create a base template application by saying Blazor New, Blazor WASM, WASM. I think this is some form of, it's WebAssembly, but I'm not quite sure what that stands for, WASM, but it sounds like an insult. Blazor WASM, and then I've given my application a name. And that'll create like a skeleton application. The only thing I modified in this application was, to start with, was the data. So that version will show you how you go do a fetch from a website. So I added a questions.json, and I stored the questions hard-coded into my application temporarily, okay? And the idea being, look, there's a title of the question, we've got 1 or 2 answers, we've got 1 or 2 pictures, and then the number of counts, or the number of people which have voted for each option. So I've got 2 questions in my application at the moment. And then I went to the pages element, and like the working model of Blazor is that you have these these pages, and they almost have like a life cycle. They're templates, but they have like a life cycle that's run on them. And it's already wired up that basically, if I go to my website / nothing, like no root, and I don't give it a URL, it will go to this page, which says hello world. And if I went to /questions, it would go to the questions.razor. If I went to /vote, it would go to the vote page. There's a whole routing system, obviously, to do that. We're not going to get into any of that. I just wanted to show you that all I did was I modified the razor views and changed one to the index. I didn't modify that. I've got one called questions and one called vote. The idea questions is like that screen which shows the question, or the slides in my other example. And then the vote is the ability for people to then vote on the options. So I've got 2 screens that I needed to develop. So on the initialization, so there's a life cycle of these pages, and you have this on-initialized async, and that happens when the page loads. So I basically say my questions object, I'm going to populate that with these, it's doing a fetch request, but effectively it's my local JSON file, my questions. And what will happen is I get an object, a questions object, which is a list of questions, which is a solid C# object at this point, and I can start using that in my application. Now the cool thing about this is it's like a single page application in that if I edit the questions, if I attach that to the screen and then edit the questions, add questions, delete questions, modify questions, my screen's going to update automatically, just like it would in Angular, just like it would in React. So you basically work with the data on this side, and just somehow magically, through the power of WASM, it somehow updates your screen and so forth. And all of this stuff happens in C#. So you're able to, at this point, write everything in C#. And you'll see that I've got a question object, and it's basically taking my JSON request, it's doing a cast into a question object, and then I've got a list of questions, which I then can bind to. So in my application, to do some binding, I've basically put a header, which says questions, and I say, well, if the questions is null, like if there's no question object, if there's nothing in there, then just put loading, because that's probably going to be fetching some data. But when there is some questions, then display a table. And it's just a table which has got title, answer 1, answer 2, answer 1 count, answer 2 count. And then in that view, I've got a little bit more. You'll notice that at the top there on line 2, I've got an inject, the HTTP client. So I'm using certain clients and certain imports. So I'm injecting the HTTP client as like a dependency injection, so I can do the fetch of that to get that data. And you'll see that in the top, you can use usings to use different DLLs and so forth as well. And then I have this little piece of logic, which basically says for each question, just loop through and print out the table. But it does a really crude thing which says, I store this variable called current count or current question. And if it's the current question, then show the current question. If it's not, then hide it. So I'll only ever show one question at a time on the screen. And then I've got at the bottom here 2 buttons. Can't really see them very well here, but they're just buttons, and they've got this on click, previous question, next question. And that's wiring it up to 2 event handlers, which are going to handle those button clicks. And those button clicks, event handlers, those they just looks like HTML, I guess. And but this thing, this event that's going to fire is a C# thing. I've got next question and previous question. And all I have is some really basic logic, which says if current count is less than question's length, then increment the current count, so increment this variable. And if the current count is less than 1, then increment decrease the current count. I can't remember what the word is. Never mind. So what means, but just by changing this current count, because my view's attached to that current count variable, as I do that, it's basically going to be changing the question that's visible on screen. So you see that if current count, that will change based upon me changing the current count. So it will be reevaluating the screen and redrawing the screen every time I press those 2 buttons. It's really simple to start like changing the UI using something like Blazor. So if I go into questions, this is the screen I just created, effectively. And I can go next and previous, and it's just incrementing that one value, and because my view's attached to that value, it's updating the current question which is visible, right? Straightforward, no problem so far. Now I want to create a voting screen, so I've got my questions which are going to be showed to the audience. Now I want a voting screen that people are going to go on their mobile application, they're going to vote. So it's a very similar view, and it's exactly the same questions that I'm importing, but I'm just showing slightly different things. I'm showing the title, answer 1, answer 2, and I'm creating 2 buttons on the screen. And those buttons are basically attached to either vote answer 1 or vote answer 2, which are these events which I'm handling. And I've also got previous and next on here as well. So it's a very similar view, but it's just showing it slightly differently. So now if I click on next or previous, and I've got these 2 buttons which currently don't do anything when I click them. What I want to happen is when I click that button, it sends a WebSocket request to my WebSocket service that someone's voted. So there is apparently a nicer way to do what I'm about to show you. And Steve Sanderson told me about it yesterday, and I spent the vast majority of last night trying to get it to work. I failed. So apparently you can now use the actual solid WebSocket thing inside of .NET, inside a Blazor application. But at the time when I was writing this, you couldn't. So what I was doing was saying, well, WebSocket exists in JavaScript, so I will just create the WebSocket there, and then I'll do this interop between the C# and JavaScript. And this is how interop works in Blazor. So in that same initialization, what I've got is I use this JS runtime invoke async, and I call a JavaScript helper function, which is on the page, and I pass the information about the URL that I want to connect to, and I create a reference back to this particular object. I have these, luckily I'm still okay with JavaScript, so I wrote a little bit of JavaScript helper functions. All this is almost identical to what I had to write in Vue to do the WebSocket communication. I've got a connect function, I've got a disconnect, and I've got a vote function. The connect function creates a WebSocket, and then what you'll see is when the WebSocket gets a message, like so when someone sends a message to the WebSocket, I invoke the C#. I want to say in the back end. It's not in the back end. It's in the front end, but it's weird. So it's invoking the WebAssembly JavaScript. So this is like a bit of an interplay. You shouldn't have to do this in future versions, I believe. This should just be all in .NET inside the handler. But at the moment, I'm having to interop with JavaScript. And the reality of Blazor is that you have to interop with JavaScript. So it's quite good to learn how to do it anyway. And I've also got this function called vote, which I can call from C#, and that will basically just send a message to the socket. So JavaScript's now maintaining this WebSocket, and I'm interrupting between C# and JavaScript to actually go and send the messages. So I have these 2 buttons on my screen. They're attached to these 2 C# handlers. And the C# handler, vote 1, all it does is it just invokes that piece of JavaScript. Vote 2 invokes another piece of JavaScript. If I was writing this with the new version, or the newer way of doing it, I would just be invoking on the WebSocket, which exists in WASM and not in JavaScript. And then when a message comes into my system, like someone else has voted, and I'm receiving the message that they have voted, it will, through that little magic that I've just created, it will invoke this C# function. And this C# function creates a little object. It takes the information, it counts, and it basically updates the status of the vote count in the application. So there was a little bit of plumbing, which completely, like, I hate, the plumbing's horrible, to be honest. But Blazor is beautiful when you are in the C# aspect of it and you're just dealing with that. And you like realize, oh my gosh, I've got lists. and like generics and like, oh, this is insanely clever. But then it's not so great when you have to sometimes invoke JavaScript and think about context and stuff like that. So what I did is I created on the same service, because I'm lazy, I created another handler called vote. And I passed that vote to a different Lambda function. And this Lambda function basically does a very similar thing to send message, but it's specifically for voting. So it just takes the vote information and then distributes the vote to all of the connected clients. So it works in a similar way as the other Lambda function. So a message comes into this service. It will be routed into the Lambda function, the vote Lambda function. So when someone clicks on the button, a message vote with a question ID and an answer ID will be sent over to my web API gateway via a WebSocket. This is what my, I don't expect you to read that. This is what my WebSocket, my Lambda function looks like. Basically, it's reading from the database, getting the connection IDs, and then posting the vote to all of the connected clients. This is the way that I do this, this marshalling between JavaScript and C#. So I've got this onSocket onMessage, and it invokes this onVote message. Ultimately, the vote request comes in to this. So as people are voting, your application will be receiving these C# function calls, and then when I modify the status, the screen, sometimes I have to call this thing called state has changed. Sometimes I don't, and I'm not really an expert in Blazor lifecycle to understand when I need to call it and how. But sometimes the UI doesn't update based upon, if you've changed objects, sometimes you're not in a position where it's going to do an update of the screen. But if you call state has changed, then it kind of makes the screen dirty and it will do a re-render. So I call that after modifying that. And what that creates is then, I've just in Chrome here, I've got my WebSocket connection connected up. And as I'm pressing the button, you'll see that messages are getting sent over to the server, and they're also being distributed to everyone which is connected as well. So that's the WebSocket basics sort of set up. So to prove that it actually works, like with connected clients, I've put two browsers next to each other, one which is on the question screen and one's on the voting screen. And when you vote, tabs, you should see like this is getting incremented in the other browser. So the other connected client is getting and receiving the WebSocket messages and updating information as it is. That is the same, almost exactly the same underlying technology as I've got in my voting application in SignalR. But what's really important about all of this is if you think the infrastructure required to run something like this compared to what I had to do with, say, SignalR. I can host the website, the Blazor website, in a static web hosting thing. I could host it on GitHub. I could host it anywhere which supports static web hosting. I connect to the WebSocket URL, which has got an API gateway. So I'll be paying for the API gateway and that requirement, and you pay based upon number of transactions, how many messages are passed. So you pay something like under $1 for 1 million requests, for example. And then the Lambda functions, well, that's not infrastructure that I manage at all. They only sit there and get invoked, and I pay for the invocation. So if it gets invoked, I pay for the amount of compute it used. I think you get like 1 million transactions free in Lambda every month. So you could build an example like this. The demo that I'm building here costs me 0 to host, nothing to host. And the cool thing is, when I go away and it's not used, which is quite often, like it's not used, I'm really paying nothing because nothing's getting used. No Lambda functions are getting called. No API gateway is getting called. I'm paying the pennies that's required by my static code hosting. And that could be that static HTML code hosting. And that could literally be in any provider on any cloud provider's hosting system. The other thing which is cool about it is when I actually host it in, say, Amplify console as a static hoster, I have like a DevOps build. So I basically check my application into GitHub. It does a real simple build off of that GitHub repository. It creates the static assets in Blazor. It pushes it to a website. Because I'm an AWS customer and my domain's registered through Route 53, then you get 3 SSL certificates. So basically, all of my domains are free as well. And so it means that you can start hosting this stuff very, very cheaply, but also getting SSL certificates which don't expire, and fundamentally building websites which are interactive and highly scalable. Like at moment's notice, this could scale to a really big sort of audience, and it shouldn't fall over. Well, it won't fall over. Mine, it won't fall over. And if it did, it would be my fault and not AWS's. I'm positive of that. But so that's what's really interesting about it. I'm paying nothing when it's idle, and I'm only ever paying if it's successful. And I think that's a really interesting model for real-time, and it's something which previously wasn't possible with other models of building real-time applications. Just to let you know, we have a whole team which work on .NET at AWS. I am just one of these people. I'm a principal advocate, which means I go around and speak about the .NET support in AWS. But there is a ton of other people, Bill at the back, on the back row there, and various other people which are here today from AWS. And then there's a whole team back in Seattle and globally which do .NET on AWS. We have thousands and thousands of customers which use .NET on AWS. And our job is to try and make it better than it was before. So trying to make the experience on AWS the best place to run .NET on the planet. And that's our objective and what we're really keen to do. So if you're interested in running on AWS and you're not sure how to do it, come speak to us at the booth. We're on level 3 at the back. If you're interested in changing the face of the world, come and work for us. We're hiring .NET developers, and for lots of different roles throughout the organization. We can tell you about that on the stand as well. And also, if you just come and speak to us, we'll give you a raffle ticket, and you might win an Echo Show 5. I think we run a raffle every day at 3 o'clock. So come speak to us. Come talk to us about .NET. Thank you very much indeed. One last thing. If you could use this system to vote for to see how the session went, it gives me instant feedback. Please just tell me what you thought about the session and give me any comments and so forth about it. And there's also the NDC kind of green-red thing at the back. Just to let you know, if you're not familiar with it, if you love the session, you think it's fantastic, you think it's great, and you think I've been great, then you just put a green piece of card in that board thing. If you think that the session's been terrible, do come and speak to me. And what you want to do at the end is you want to put a green thing in that bin. Thank you very much indeed. Cheers.